Good afternoon, Professor. This is my weekly presentation, and which is my personal timetable as well. And uh, I usually attend research group meeting of RFIC, and on every Friday we have to attend a biomedical physics class on Friday. And this week I have research with one paper, and today I'm going to represent that paper uh, through my presentation. And also I've worked on two assignment of MMIC and electrolysis, and today we have submission for both assignment of MMIC and electricals. And in current upcoming week, we have to attend this meeting, Monday meeting, research group meeting, and biomedical physics class, which is on every Friday. And again I have to prepare two more assignments of one more assignments of MMIC and electricity, this with these two different subjects. And I will research on more about this medical radiometer for medical sensing application using this different reference noise source, and will research for more new scientific paper with the same research topic. Yes, will present my presentation. The title of this paper was Intelligent Thermal Comfort and Controlling System for Building the Base of IoT and AI. This I have also mentioned the uh, DOI number of this paper. Is I have mentioned a number, paper number. And first I am going to explain from starting that what was the abstract introduction part of this paper, and then all the methods and what techniques has been used. So abstract of this paper was, as we are aware of, there is a demand for intelligent device of indoor and outdoor living environment, which keep on increasing, and for improvement in technology also. And this uh, in this traditional control system is adjust the living parameter, which cannot meet the better requirement of human comfort intelligence. As in this paper is about build of intelligent thermal comfort and control system, which is based on IoT, Internet of Things, and intelligent artificial intelligence. Using IoT and AI, this system has been developed. And in this paper, various algorithm and prediction method has been analyzed, and it automatically complete the series of operation through IoT hardware device, and in building with key modulation. And the code is developed and debugged by Python to establish a model of energy consumption prediction with the environmental factors such as temperature, humidity, and radiant temperature and air velocity for thermal comfort indicator. In this simulation, 1700 data set has been trained, and output of predicted mean value is compared with the real figure, and result shown in the performance of this system. And control the energy saving and comfort. And next comes the introduction part of this paper. In this As I said, in this paper, this has been done using IoT and AI, and the increase in energy consumption has gradually affected the attention of industry, and cutting edge technology on big data, cloud computing, machine learning, and and intelligence algorithm compared with the traditional architecture design theories, and to improve the life quality of building occupant and build the suitable living environment is valued in technical field. Computing power of hardware had not yet meet the need of scientific research, and building energy consumption cannot achieve the accurate prediction, so error relative large, and development of trends of computer science, applied mathematics, and statistics and semiconductor hardware has brought this irritative progress in artificial intelligence technology. So problem of this has been solved with AI technology. And as this topic is about material, what material and method has been used, and this in this method they had used IoT method, Internet of Thing, uh, and system contains the sensor, controller, and other IoT device, and data is collected, analyzed in intelligent algorithm, BP neural network, and neural fitting network, and the relation between the actual comfort temperature occupant and input output variable, such as predicted mean value is established. Now this figure is about system working mode schematic the diagram, and it works in clockwise, and step by step I'm going to explain what comes first and next. In this first, the temperature humidity detection system to collect the data. First data is collected through air temperature, and symbol is like TA, average radiant temperature TR, air velocity is VA, relative humidity HR, metabolic rate is MET, and clothing situation is CLO. And in next step, after you use the data which is collected in first step using IoT sensors to obtain PMV value. What is PM value? Is a predicted mean value. Through this, through using Figure method and BP neural network method, this is the algorithm which is done using Python to establish this multivariant logical relationship. Use the statistic and analysis method to establish the relationship between the optimal comfort of the occupant and predicted mean value is done during the third step uh, in this yeah, in this predicted PMV model, predicted mean value model is run, and in this calculation part has been done, then you get the output as a predicted indoor thermal condition. And next, the in predicted trend, temperature, humidity, wind speed, and PM value in the room, adjust the parameter of each controller using this controller to complete the goal of indoor thermal comfort. Then predict the optimal comfort of room occupant over a next period and compare with the real measurement value. Collect the feedback from the user to see if they reach the optimal comfort temperature. Finally, it achieves the intelligent control of building thermal control and control system. This helps in achieving the uh, system which we want as a final result. And this with the continuation of the same topic, what material and method has been used. As I said, it has been used Internet of Things, and it contains sensor, controller, IoT device. And in BP neural network, calculate the relation between the actual comfort of the occupant and input output variable of mean value. A BP neural network is this is the structure of BP neural network. Like, this is input, and the middle is about the processing, how processing of data has been done, and then the third step is about the output. This is whole about the BP neural network. This is the structure, how to use this algorithm using Python. And this figure is about a wireless sensor network in physical activity recognition and monitoring. I have get this figure in this paper. I have mentioned the link also in of the paper where I get this figure, from which paper I get this. As I said before, the one figure of how it is predicting using IoT and artificial intelligence. This figure also runs in clockwise, and it will be helping understanding more how it is being developed. So as you can see, this is a this actor has an ECG sensor. Various sensor has been there, wristband and motion sensor, and phone and PDA spirometers sensor has been used. You can see in this figure. And this sensor is being connected with the wireless sensor network, like means the receiver side, like Bluetooth receiver, RFID receiver, Wi-Fi. And it has then it connects to the access point, from where all the data been routed using router and access point. And then it sends the data to IoT cloud, and then IoT cloud store the data in database, like data center, personalized data, and data storage. In this paper, they had used MySQL Apache as a database to store all the data. And then comes the output with front end part. Front end can be like can be in PHP or Python, any language we can use to showcase our data. Like in non-medical application, like there is a fitness tracking and smartphones, and in medical application, remote care, emergency. And how this system schematic diagram has been working uh, in this first is like by using IoT sensor, air temperature, radiant temperature, air speed, relative metabolic and clothing situation has been collected, data is collected. Then Figure method has been used, and back propagation means BP neural network method is being used to calculate PMV value. What is PMV value? Predicted mean value. And then the comes at the output or the predicted input thermal comfort condition. And using the various controller, you can predict the optimal comfort temperature, and then the feedback from the user reaches the optimal comfort. Finally, it reaches the intelligent control of building thermal comfort system. And next topic is about which hardware device and data collection has been used. I will explain this topic using hierarchy method. In this hierarchical method, what hardware has been used, and some detail or some sort of has been done, how the data collection and procedures has been done. So first is the monitoring system. In monitoring, first we have to monitor the system, how it can monitor system hybrid as a sensor module. Now in sensor module comes with the many sensor like temperature sensor, humidity sensor, wind speed sensor, but we are not using about we should not focus much more about humidity sensor and wind sensor, so I'm more focusing about temperature sensor. In this paper they had used a WBGD thermometer, wet bulb globe thermometer, and the model number of this thermometer JTR10C WGT, and is used for monitoring the global radiant temperature and indoor temperature at the same time. And this device has been placed in such a way in that direction that all the uh, temperature has been sensed. So it is placed in that way, and this in this how data collection and procedure has been done, I will explain through this diagram, this diagram. In this IoT data collection, which is called as a, you can call as a, this is like collecting module, and the delay relay module is about receiving module, and the last is about storage module. So using IoT data collection sensor is used to collect the indoor temperature. In this collecting module, light intensity, wind speed, temperature, humidity, this can be measured using the temperature sensor and everything, and it is and power supply is being used to receiving module and a storage module to pass the data from one module to another module. Then the data is collected, and wireless, as I said, RFID or Bluetooth or some wireless device is being connected, wireless data transmission device, and uh, then in receiving module it comes to the gateway, like routing the nodes all, and wireless transmission has been done, and then the storage system comes into the picture, like data storage and data processing using algorithm, BP neural, and various algorithm has been implemented for storage of this, and controller controls all the data. And then suppose there is a measurement ranges -20 to 60 degree, and the accuracy plus or minus 0.5 degree, humidity measurement ranges to 0 to 100%, and uh, this in this as I said, this topic is about data collection and procedure, and the sensor, uh, as I said, it has been used IoT, which is advanced technology. So it sends in a real time and store it and analyze the all the data, and then send to the system. And they had specified the all the temperature with the specific symbol which has been classified, like air temperature is symbolized with TA, average radiant TR, and speed and relative humidity, metabolic rate, and clothing. The measurement command is transmitted and multi-parameter sensor group, and then the routing node turn the store of the computer hardware. In there, for collecting and storing the data, they had used CSV file, means common spreadsheet values format, to automate group to facilitate later data processing. And in the controlling phase, after receiving all the data from gateway and the receiving model and uh, control module, the controller operates according to the command and returns the controlled result. This experiment has been done on September 2019 and ended at 30 September 2019 for total 30 days, and system start at 8 a.m. to 6 p.m. Parameter recorded at every 10 minutes. As I said, for every temperature sensor they had specified specific symbol, and that's it. I have studied with this paper, and there is more about this paper, what like deeply source code has been mentioned, which I will explain in which I will study and present that all Python code and everything in next personal timetable. And thank you for the uh, this Monday presentation. Thank you.